So, so we'll talk about the computer vision versus computer graphics, more about like what are they and the application, some application about computer visions. So for computer graphics, it's creating image videos from Scratch using computers. And for computer vision, is studying and understanding the content of image by modeling the scenes. So in another word, for computer graphics, it's like you are having some models, like maybe a ball, and you're trying to draw a ball in an image. So you're trying to represent the ball, the model, or whatever, into an image. And for computer vision, you are trying to making model from an image. So they're inverse. One is having model making image. One is having image making model. So assume like we have a model called a big cat man, then we will draw an image like this, and this is what computer graphics does: it's draw image or draw graph from model, and then we might interpret this image as a stupid creature or like big head, whatever. And this process is called computer vision because we are building models from the image or graph. So for computer graphics, we were trying to get some features from the image, like maybe recognize what the object are. Is it an animal? Is it a cat or a dog? Or we might be analyze the motion if there are several images. So it's like having video people running. We can interpret it as a consecutive image, then analyze how that person runs. Then we can build 3D model of that person if the computer vision is good enough, I guess. And for computer graphics, you are having a model, so maybe that big head man. Then we're trying to render it using ray tracing, using whatever model we have, trying to make it into an image. And also, if it's we want to make that person move, then we have to create a series of image, which will become an animation. So that will turn into a video because it's a series of images. And the application for computer vision is more like recognizing stuff, as we said. So maybe for fingerprints, like you scan your finger, it scans your fingerprint into an image and trying to compare that to detect whether you are the owner or not. Or like, and for computer graphics, you can, one big part is like Disney movies or Disney Entertainment, I don't know. They're trying to like creating animation, which they build the model first, then like render it into an image, into a 2D image, of course. And another application is like on my cell phone, there's a dictionary app, and I scan it. I'm using my camera to scan some words, and it recognizes the word every. So that's one way of computer vision, because in this part it might be cell phone vision or whatever, because it build a model, a word from actually the word every. And another big part for computer vision is the edge detection. So intuitively, what we want to do is we're using edge to replace those, like edge should be like those change suddenly, like the color was red then immediately become black, or like the surface is continuous then immediately it discontinuous, such thing like this. One useful way to detect edge is called Canny edge detection. What it does is apply Gaussian filter to smooth the image, and then find the intensity gradient of the image. Then apply non-maximum suppression to get rid of the superior response to edge detection. We'll talk in detail soon. So let's start with Gaussian filter. So I won't talk about the numbers or those formula, but you can look at the graph at the right. So the straight line is actually the impulse, and the Gaussian filter turn that straight line into those curved line. So what it does is like this. So imagine the height is the intensity, and it's actually a 1D, a 1D stuff, just a line with color. So the higher that line is, that means that part is darker. So we have two dark points. One is super dark, one is okay dark. And if we apply Gaussian filter, it will smooth the dark place, both dark points, and in result it will turn into a smooth. Maybe you can see it's like a shading area, a shading line. It's not a line completely white with a black, then a black. It's like a line of gray, and sometimes the gray is higher, sometimes the gray is lower. So Gaussian filter is smoothing the image. Like the original image, we can smooth it into like a very vague image. Why? So for Gaussian filter, there's funny thing, like we can get the edge here. By the original graph, remove the smooth graph, you can see like the result will be kind of like the edge. And if we add that result back, we can actually sharpen the image. But that's not Canny edge detection tool, so we'll talk about what's gradient intensity. That's more likely the change. You can treat it, I won't talk about the formula, but you can treat it as like the change of the, how big the change is of that gradient. So like in this image, like, so the greatest part is those line where arrow points to, because there's a abrupt change from very plain to very dark. And the second one is also the same. And the right below corner is pretty light, then it immediately turns to dark. So why are we applying Gaussian filter to smooth the image? Because those derivatives can amplify the noise. So look at the image at the right. So for the first one, you can see we're trying to add in the noise a bit for each row. We are trying to add the noise a bit and later intense the noise. So the first one is completely without noise. So as you can see, the second column is it's what we want, the value of gradient. So you can see there's a big change of that. So, actually it's the third column, there's a big change, so there's a two big change, so those are the two edge we want. But then if you adding a little bit more noise, you can see you can't even tell like where exactly is the biggest change part. So as the noise gets bigger and bigger, you can't even tell like even the first derivative whether there's an edge in the first derivative or not. So the point here is like the noise can actually be very annoying if you're trying to detect the intensity of gradient. So by smoothing the image, we're trying to reduce or remove the noise. So that's why on the Canny edge, at the beginning, it will try to smooth the image. And then at the last part, okay, after smoothing the image, we'll get the gradient, and the gradient should be pretty good. And we will set a threshold, so like if that intensity is big enough, it will become an edge. But later we're facing a second problem. It's actually not a big problem. Like the edge we got might be the left part, so it's pretty thick. So then we apply the non-maxima suppression to make it thin. The way this works is like for each pixel, you check along with its gradient line. So for the first image, the gradient line is actually from the center to the point. It's a line like from the center to that point. So you can see like the most inner part is the most intensity part, so that part will be preserved. The rest, because those are less than the inner part, those will be removed. So that's how non-maximal suppression works. It's trying to remove, trying to preserve the local maxima and remove those like not maxima point. Thus, it can sharpen the edge. So let's look at the stuff. So at the beginning we get the norm, then we set the threshold because we don't want so many details. And you can see like in the third graph, it's actually you apply the thresholding, and you can see some edge is kind of thick, some is thin. Then we apply the non-maximal suppression, which will thinner the edge, and then that's it. So yeah, that's all we have here. All right, thanks.